If you take a beaker of dice and just spin it around, eventually they'll all arrange into perfect stacks, fitting into the container in the most efficient way possible. This will actually happen with any solid particle of any regular shape. If I take a box of nails, for example, and shake it for a while, eventually they all align. Shake a bunch of hard spheres and they'll organize into a face-centered cubic pattern. All hard particles will tend to spontaneously organize themselves. It seems like there's some force making these shapes align in a certain way, but why? Well, remember, the entropy of a system tends to increase whenever you do anything, and that's true in this case as well. The orientational entropy of the system decreases, but this loss in entropy is way more than offset by a huge increase in translational entropy of the system. What I mean by this is that when the dice are disordered, they take up this amount of volume. But once the dice are ordered and you look at the same volume, you can see that there's this new amount of free volume that opens up. This makes it so that the amount of free volume per die increases. So if we wanted, we have all this space above for any die to move anywhere it wants. And when we increase the number of places that a die can be, it means that we've given the whole system more possible states that it could be in. And entropy is defined as the number of possible states of a system. So the entropy increases. So any solid shape has a tendency to maximize face-to-face alignment. This creates more free volume. And that means that overall the entropy is greater in an ordered versus a disordered box of shapes of the same volume. In fact, when I stretch out this rubber band, the reason it springs back isn't due to any elastic force pulling it back. It's just due to the entropic force. Let me show you what I mean. If I just take a single molecule of atoms strung out in a line like this, there are no other forces acting on them other than the fact that they're connected to each other and they're jiggling around like atoms do. They're free to move and fold in any direction. But if I disconnect this end here, look what happens to the string of atoms. They shoot to the other side and curl up. There isn't some force that's making them coil together like this. It's just that statistically, there are more ways to be in a coiled state than a straight state. Even if I pull it and stretch it out again, it springs back like a rubber band. In fact, I have to exert a force to even get it straight again. Force equals temperature times the change in entropy divided by the change in distance or length that we stretched it out. So this emergent force happens purely from the fact that entropy increases over time.